Good morning, 6th grade. It is Friday, January 10th, 2020. You officially made it through the first full week of the 2020 half of the school year. So, woo! Let's take our step back and look forward. Okay, so this week was the week of January 6th through January 10th. For integrated science, you started your climate change project. You should have completed checkpoint 1, effects of climate change. And this week, you're going to be working on checkpoint 2, this week coming, I apologize, 13th through the 17th. Checkpoint 2, climate change in a bottle. So, climate change in a bottle. This is the lesson that I prepared for you. It has all the resources that are listed in a little bit more detail and a little less kooky. The purpose of this lesson is to develop the skill of constructing an evidence-based explanation by explaining what happened in the climate in a bottle experiment and how that is known. So you're going to read these slides to receive an overview of the experiment. So we have climate change in a bottle, modeling the greenhouse effect. So part 1 is conducting an experiment. How does the sun warm the earth? Sun sends energy by radiation. Greenhouse gases like CO2 trap the energy and keep the earth warm. How do we know that CO2 actually warms the earth? Well, we do an experiment. Our question is, does extra CO2 in the atmosphere actually make the temperature warmer? So to answer, we need to make a model. So how can we model the earth? We're going to use plastic bottles. So the bottle is the earth, and the air in the bottle is the earth's atmosphere. How are we going to model that extra CO2? A little chemistry, baking soda and vinegar. So that's going to be our extra CO2, and how we're going to model the sun? A light bulb. Simple. We're going to use a thermometer to measure the temperature. So we need 2 bottles, and bottle A is going to be normal air. So you just put the lid on the bottle, done. Bottle B is going to have the extra CO2. So that's going to be the vinegar or baking soda. And you're going to put both by the light bulb. Do not put the light bulb on the bottle. You will melt it. Just put it close to it. And then you're going to make a hypothesis of which one will be hotter. Then you're going to draw your model and set up your bottles. So the only difference between the bottles is that one that has the extra CO2. They're going to be the same shape and color for the bottles. The amount of water that you're going to use is going to be the same. The thermometer will be the same. The thermometer location will be the same, and the distance from the light bulb will be the same. Everything's the same. So we have that control. The only thing that's going to be different is that the one bottle has extra CO2 from your little mixture. So when you run the experiment, you're going to record the starting temperature of both bottles, and then whenever you're ready, you'll turn the light on. You're going to record the temperature every minute, and you'll do that for 15 minutes. So whenever it's time to clean up, you'll pour out the water, throw away the tape, save the bottles and the thermometers, and the papers and wherever you keep them. Part 2, you draw your conclusions, constructing an evidence-based explanation. So you're going to use the skill when you're explaining what happened in the experiment. And this has 3 parts: the claim, so what you're saying; the evidence, what proves what you're saying is true; and your reasoning, why that happened. So you have a big idea, evidence, and reasoning. So this is an example. Was fast food healthy? Your claim is, no, fast food's not healthy. Well, why is it not healthy? Your evidence says the average piece of fast food has over 500 calories and lots of fat and sugar. What's your reasoning for that claim and your evidence that supports it? While foods that have lots of calories, fats, and sugars can cause health problems like obesity and diabetes, because fast food has these things, it is not healthy. And there's another example with plant growth experiments. So your turn. Once you're all done with the experiment, you're going to answer their questions and the results and conclusion section of your checkpoint. So you're going to watch this video to learn how to set up the experiment, and you can watch this video to observe the experiment, and then review this document to prepare for the experiment. You will explain by answering the question, how does the sun warm the earth? You'll complete this activity at the beginning of the checkpoint to check your understanding of climate change and the greenhouse effect. Then you're going to demonstrate the skill of constructing an evidence-based explanation by conducting the climate in a bottle experiment and explaining what happened and how that is known. So that will be the checkpoint, the actual checkpoint you're going to turn in. So this lesson, you take all the steps that you need to submit that checkpoint, and then express, self-evaluate, and tell me how you believe that your evidence-based explanation skills has been enhanced. Okay, so that is that, and let's look at math. So this week you had cool downs 1, 2, 3, and 4, and you had a day, which is today, to work on your portfolio. Remember, you only have to do one portfolio problem per unit. You do not have to do more than one, but you need to do one. So there are 3 days built in for you to do that. And then this week coming, you're going to do cool downs 5 through 9. Let me here, 1, 2, 3, 4, 5. You have, as always, the materials that you need to submit the cool down itself. And you're going to do how many in 2, a partially filled container, funding a camping trip, refilling a soap dispenser, and dividing 1/3 and 3/5. And in our focus area, let me back here, for dividing fractions, I have the lesson for objective 1 and the lessons for objective 2. You can break this down so that you can walk through how to do what. All right, friends, I believe that is all, except for I'm going to attach the link to the survey below this email. I only had one friend complete the survey, and I'd really like your feedback, even if it's no, I'm not interested, just so I know if you would like virtual learning labs or community-based learning labs. So please fill that out as soon as you can. All right, friends, have a great weekend.